Hello, how are you?
Hello.
Can you hear me? You can, right?
Yeah.
Excellent. Okay, shall we get started? Or let's wait for actually one more minute and see if there's more students coming in.
Yeah, sure.
Okay. All right, seems this will be just two of us. Have you got your marks for problem set two?
No, I think the lecture did not post online.
Okay, that's fine. Let's get started. Let me share my screen. Can you see it?
Yeah.
Okay. So first thing we need to talk about here is just a quick review on last week's lecture. So now we're talking about firms, right? You know, in previous weeks, we've been talking about consumers and their utility, their indifference curve, all those kind of stuff. So what's the difference between consumers and firms? A consumer takes goods, right? If you remember, we have two goods, X1 and X2 and Y1, Y2. And firms takes inputs, right? What are the inputs? That is labor and capital, okay, L and K. And consumer turns goods into utility, right? Means how happy they are, how satisfied they are. However, firms takes the inputs into outputs, okay? What is output? It's simply Y over here. So the process of which is determined by utility function for consumers, but now this is about production function. And in a sense, how do we write down the production function? That is Y output equals to a function F of L and K, which L is labor, K is capital, okay? So the cost of the process for consumer is expenditure, right? How much money they have. However, for firm, it's a cost, okay? The cost of labor, the cost of capital. So the consumers maximize utility by choosing the consumption bundle, right? If you remember X1, Y1. And firm, they choose input combination, means combination of L and K, which will give them the lowest cost or the highest profit, okay? So in a sense, the producers care about what? Care about profit maximization, care about cost minimization, okay? So unlike utilities, output is cardinal, okay? Which means magnitude matters. So unlike a consumer, a firm does not have a budget constraint, okay? So we'll have infinite budget as long as they're profitable, okay? So which means, why is that? Because think about this, as long as you can make money, then the banks or investors are willing to borrow your money, right? To lend money to you. So we consider the firms as they have infinite budget, okay? As long as they're profitable, okay? We already know what's a production function. And number three, we need to talk about isoquants. What is isoquants? That's a consumer, that's the counter lines of the production function, okay? Which is just like the indifference curve for consumptions, okay? So counter lines of the production function are called isoquant. Each isoquant plots the combination of L and K, which yields the same output level, Okay, remember here, same output level instead of same utility level. Okay, so we can draw this as a downward sloping line, a curve that on the vertical axis we have K capital, on the horizontal axis we have L, which is the labor. Okay, so obviously Y1, Y2, Y3, that different level of output levels. Okay, obviously more to the right hand side, the higher the output is. Okay, so which means Y3 greater than Y2, Y2 greater than Y1. Okay, next we concern the slope of the isoquant. Okay, so since we have Y equals to FLK, which is the production function, equals to a constant, that's our isoquant. It means the change of L over change of Y over change of L times change of L plus change of Y over change of K times change of K equals 0. Okay, this is simply by taking their derivatives. Okay, so in the left hand side, change of Y over change of L times change of L, that's change in Y due to changing L. That means if you change 1 unit of labor as input, how much the production or output going to change. On the red part, that's changing Y due to changing K. That's if you change 1 unit of capital, how much of the output you're going to be changing, okay, which equals 0. By rearranging this equation, what we get is change of K over change of L will equals to minus change of Y over change of L over change of Y over change of K. So what is change K over change of L? That's something we call the marginal rate of technical substitution, okay, or MRTS, or the slope of the isoquant. Okay, so the red square says minus change Y over change L. What is change Y over change L? Simply, this is the marginal product of L, right? It's taking first derivative of the production against change of labor. We can also write this as FLLK, okay, FLLK, which means marginal product of labor. Next, bottom one, change Y over change K. That's simply the first derivative of production against change of capital. So this is MPK. MPK, or the marginal product of capital, or FK, LK, okay, FK, LK. So more onto the margin rate of technical substitution, which is the slope of the isoquant. MRTSLK can be written as minus MPLLK over MPKLK, okay? Or if you are not afraid of the mathematical symbols, you can write it down as MRTSLK equals to change of FLK over change of L over change of LK over change of K. Then you put a minus sign in front of it, okay? Simply, this is similar to marginal rate of substitution. If you remember, the slope of a utility function is MRS. Here, the slope of isoquant is MRTS, okay? Intuitively, MRTS measures the amount of K that can be reduced when there's 1 more unit of L. So in a sense, it means if we're trying to keep the production level constant, how much of K that you need to sacrifice or you can reduce when you are adding 1 more unit of L, okay? In the end, you will have the same production level, okay? So next we have diminishing marginal returns. The series says law of diminishing marginal return says, fixing the amount of output at the input, the marginal product of an input eventually diminishes as it is quantity increase, okay? So which means when you increase more labor, the marginal product of labor gonna decrease. When you increase more capital, the marginal product of capital will decrease, okay? So how can we see this? As you can see, we have 3 isoquants here. The first one presenting output level 55, then 75, then 90, okay? So from the first Y1 to Y2, the change of Y is 20, okay? That's when you add 1 more unit of labor and add 1 more unit of capital. How can you say that? Okay, you can see over here. Then we becoming over here, right? That's an increment of the output level, of the input level. It has giving us an increase of output of 20 units. However, if you add 1 more unit when labor equals to 3, capital equals to 3, then what you have is this isoquant, okay? Here, by adding one more unit of both inputs, your output has only increased 15. So which means your output is increasing in a decreasing rate, okay? We're not saying that's decreasing, we're saying that's increasing, but in a decreasing rate, okay? So therefore, this is diminishing marginal returns, okay? By adding one more unit of labor capital, the effect of the adding inputs is getting less, getting smaller, okay? So that's diminishing marginal returns. Number 6, own effect and cross effect. So when there are two inputs, in our case, K and L, we typically impose an assumption of this cross effect that magnitude-wise, the effect of an input's marginal product due to an increase in the particular input is bigger than due to it increasing the other input, okay? So that is simply saying that FAL times FKK minus FAK, FKL greater than 0, or simply FLL times FKK is greater than FLK times FKL. Okay, that's very simple. This is condition sometimes known as own effect is bigger than the cross effect. So as you can see, FL, KK, they're only talking about the effect of changing labor itself and changing capital itself. So that's why we call it own effect, okay? However, here, right-hand side, LK, that's the effect from changing one unit of labor, and FKL, that's changing from one unit of capital, okay? So that's something we call cross effect, okay? Cross effect. So how do we write down FLL, FKK, FLK, FKL? So FLL, it's simply the change of marginal product of L against change of L, okay? That's how much change in the marginal product labor with one unit change of labor, okay? And FKK, that's a change of marginal product capital against change of K. In other words, that's how much marginal product of capital gonna change if you change one unit of capital, okay? That's something we call the own effect. As for the cross effect, that's FLK and FKL. That's, for example, FLK, that equals to change of marginal product of L against change of K. That's when you change one unit of capital and how much change of marginal product you're going to induce, okay? FKL, that's simply change of marginal product K against change of L. That's how much your marginal product of capital going to change if you change one unit of labor. And next, we'll have something called diminished marginal return to technical substitution. That means when you're having higher inputs, L and K, the MRTS will reduce, okay? So therefore, we'll be having diminished marginal returns and more diminished marginal rate of technical substitution. So if we assume that we have diminishing MRL and we have diminishing MRK, that means FL smaller than 0. And we also have FKK smaller than 0. Then we also assume that own effect bigger than cross effect. Then this will imply that diminishing marginal rate technical substitution will be granted. Okay. So that's a simple, just a review on the course content. Do you have any questions?
No, all good.
Okay, cool. So with all those things being discussed, we should also talk about the real meat of this week's tutorial, okay? So when we consider a firm's decision problem, if you think about consumers, their decision problem is to maximize their utility, right? But for firms, they don't have utility, right? So they consider profit maximization, okay? Therefore, we have one assumption that the firm is a price taker in each input market. Means there's not monopoly or duopoly or anything, okay? So if we let P equals to output price, W equals to wage rate, R equals to capital rental rate, then we can define the profit maximization problem. However, before doing that, we need to understand what is short run and long run. In short run, for the scope of this week's tutorial, it's period of which the quantity of the at least one input is fixed. Okay, so in this tutorial, we will be fixing the capital. Okay, so in the long run, period of time in which the quantity of all inputs are variable means both L can change and K can change. However, we're talking about profit maximization in the short run, right? So which means we're fixing K. Therefore, we're writing it as K hat. Okay. So therefore, the profit maximization problem, because we become that we want to maximize pi, which is profit function, equals to the price P times the production function, which is giving you quantity FLK bar, minus the cost. Okay. Minus what's the cost? Total cost equals to variable cost plus fixed cost. The variable cost here is wage rate times the quantity of labor you're going to employ. All right. And what is fixed cost here is capital cost, right? Because we assume that capital is not going to be changeable in the short run. So we have R, which is capital rental rate times K hat. Okay. So, but we've solved this by applying the first order condition. Okay. So which equals to P times FLK bar minus W equals 0. Rearranging this, we have P times FLK bar equals W. Okay. So in the right-hand side, this is the value marginal product. Okay, so that's the increase in revenue due to 1 unit increase. And W is simply wage. Okay, that's the uncertain in cost due to 1 unit increase in L. Okay, so short run unconditional labor demand. Okay, this equation is something we call the short run unconditional labor demand. We also need to check the second order condition, right? Because we know that by having first order condition equals to 0, that means we might have a minimization point or a maximization point. To ensure that we're having maximizing profit instead of minimizing profit, we must have second order condition smaller than 0. Okay, so that's short run. In the long run, the quantity of both inputs are variable. So therefore, we'll be having two first order conditions against W and against R. Okay, that's wage and the capital rental rate. Okay, so with those two equations, and we divide those two, then we can have FLLK divided by FKLK equals to W divided by R. Recall that this is simply the minus marginal rate of technical substitution, right? So we're having the tangency condition here, MPL over W equals to MPK over R. Okay, again, we need to check the second order condition. However, now this not only have own effect, but also have cross effect, right? Because both the capital and labor are allowed to be variable. Okay, so therefore we need to check the Hessian matrix. Okay, we'll talk more about Hessian matrix later. In the sense, Hessian matrix is simply price times the own effect and the cross effect. Okay, we already know how to calculate the own and cross effect, so we're not going to talk about that. So in a sense, we must satisfy the FL smaller than 0, FKK smaller than 0, and we also have to satisfy FL times FKK minus FLK times FKL greater than 0. If those are satisfied, then we say the second order condition is satisfied. Then other step will be exactly the same as before. So without further ado, let's look at question number 1. We have the production function as FLK equals to 4 times L to the power 1 over 3 times K to the power 1 over 3. And we know output price is 3, so P equals 3. Rental rate of capital R is 1, so R equals to 1. So we first consider from in the short run. Okay, in the first run, short run means only capital, only the labor is changing. Okay, so we know K bar will be fixed at 64. Okay. Is there diminishing return to labor? Explain. Okay, so we remember how to calculate diminishing, right? Okay, so simply all we need to do is just to first of all calculate the margin of productive labor, MPL, which is first derivative of the production function against change of L. Change of FLK against change of L, it's simply 4 over 3 times L to the power of minus 2 over 3 times K to the power of 1 over 3. Okay. Then when you take a second order derivative, the second order derivative is simply the own effect of the labor, right? FLLK, which is change of marginal product of labor against change of L. This is something easily can be derived. Okay, so this is simply minus A/9 times L to the power of minus 5/3 times K to the power of 1/3. Obviously, because L and K are positive numbers, and there's a minus sign in front of it. So we know FL will be smaller than 0. Okay, if the own effect is smaller than 0, then we know this is diminishing return to labor. Okay, so the rule of thumb is if FAL or FKK, which is own effect, are smaller than 0, then this is diminishing marginal return. Sorry, what am I writing? So this means DMR, diminishing marginal return. If it equals to 0, this is constant marginal return. Okay, if it's greater than 0, this is increasing marginal return. Okay, that's simple rule of thumb for you to remember. Okay, that's question A. Question B, suppose that wage rate W equals to 1. Find the perfect maximization choice of L. Okay, that's pretty easy, right? Because we already talked about in the short run, how do we find the perfect maximization point? It's simply taking first order condition and second order condition of the perfect maximization problem, right? So that's pretty simple. Let's write down the perfect maximization problem first. That would be, I'm trying to maximize the pi, which is perfect in the short run, which equals to P times FLK, which is just revenue, right? So we know this is simply revenue. Why? Quantity times price, right? Quantity is denoted by the output, okay? It's revenue minus the cost will be the profit, easy, right? How do we calculate the cost? W times L, that would be our variable cost, and R times K bar will be our fixed cost, okay? So just plug in the value now. I know P equals to 3, which is given, okay? 3 times the production function. The production function is given by 4 times L to the power of 1/3 times K to the power of 1/3, where we put a K bar on top of them, right? Because we know K bar equals to 64, okay? Minus wage is 1 minus 1 times L minus R times K, 1 times 64. K bar is 64, which is known, okay? So now if we know K bar is 64, so we plug in the number, this now become 12 times L to the power of 1/3 times 64 to the power of 1/3 minus L minus 64. So by rearranging this is simply 48 times L to the power of 1/3 minus L minus 64. So as you can see, this is partially just simply a function against L, right? Why is that? It's because we already know the capital is fixed at 64, so we don't have to do first order condition against K anymore. So the only first order condition we're going to check is change of pi against change of L. Okay, so we know this is simply 48 times 1/3 times L to the power of 1 minus 2/3 minus 1 equals 0. Okay, why is that? Which is simply bringing 1/3 to the front, and 1/3 minus 1 power will equals to minus 2/3. So the power got left is minus 2/3. Okay, and from the constant rule, okay, from the constant rule, 64 will become 0, so it drop out. And from the power rule, L will become 1. Okay, if you remember, we talked about this in the first week's tutorial, you should know. So simplify this, this will become 16 times L to the power of minus 2/3 equals to 1. So by putting 16 to the right hand side, we have L to the power of minus 2/3 equals to 1/16. So therefore, L will equals to 16 to the power of 3/2, which equals 64, right? Because if you take square root of 16, that's 4. 4 to the power of 3, that's 64. And this will be our perfect maximization of labor in the short run. Okay, or we call this short run unconditional labor demand. Okay, however, that's not finished. Always remember to check a second order condition. Okay, second order condition of L equals to 16 to the power of 3/2 is simply minus 2/3 times 16 times L to the power of minus 5/3, which is smaller than 0. Okay, because there's minus sign in front of it, and the power of this is simply positive as long as L is positive. Okay, obviously we can't take the negative values for the labor, so therefore minus something of positive is negative. So therefore, we say second order condition is satisfied. Okay. So how do we get the profit maximization output? It's simply we're plugging L equals to 16 to the power 3/2 into our production function, right? So therefore, our short run optimal level of output will equals to 4 times L to the power of -3 times K bar to the power of -3, or 4 times 16 to the power of 3/2 times 3/1 times 64 to the power of -3. As you can see, 3 will cancel out. This will simply equals to 4. Okay, 4 times 4 times 64 to the power of 1/3 is 4. 4 times 4 times 4, which is 64. So our profit maximization output level will equals to 64. Next one we need to do is substitute optimal L into the profit function. Therefore, we can get the profit, right? Remember here we only get the output level. Our end goal is to get the profit. Okay. So pi star SR, which means the short run profit level, optimal profit level, is 48 times L to the power of 1/3 minus L minus 64. Plugging L, which equals 16 to the power of 3/2, okay, we get 64. So this will be the maximize the profit equals to 64. Okay, that's pretty easy. Just following the step that you need to check: first order condition, second order condition. All right, pretty simple. Question C. Now suppose wage W equals 2. Okay, we need to do simply exactly the same thing again. The only difference here is it used to be that L equals to 1. Now it used to be W equals to 1. Now W equals to 2. Right. So repeating the same process, we know the short run profit maximization problem is maximize pi SR, which equals to the profit, the revenue minus the cost, right? Which equals to 3 times 4 times L to the power of 1/3 times K bar to the power of 1/3 minus 2 times L. Okay, remember that's a difference here. Minus 2 times L minus 1 times 64. Again, K bar equals to 64. Okay, in the end we get 48 times L to the power of 1/3 minus 2L minus 64. Okay, then what's next? Next, obviously we check first order condition, right? By taking first order condition of 48 times 1/3 times L to the power of 1/3 minus 2L minus 64, and we set it equals to 0. All we get is 48 times 1/3 times L to the power of minus 2/3 minus 2 equals 0. Again, now the difference is this minus 2, okay, instead of minus 1. So what we got is 16 times L to the power of minus 2/3 minus 2 equals 0. Okay. By rearranging this, we have 16 times L to the power of minus 2/3 equals 2. So L to the power of minus 2/3 is 1/8. Okay. So therefore, our L will equals to 8 to the power of 3/2, or 16 times square root of 2. And this is something we call the short run unconditional labor demand, or profit maximization choice of labor in the short run. Okay, LSR star. Okay. So next thing, obviously checking second order condition. This will equals to the previous equation, which is 16 times L to the power of minus 2/3 minus 2. Then we take first derivative again. Okay, then this becomes second derivative of the profit against change of L, which equals to minus 2/3, just putting minus 2/3 to the front, times 16 times L to the power of minus 5/2/3. Again, minus 2/3 is greater than 0. It's smaller than 0. So therefore, the second order condition is satisfied. Next thing, we follow exactly the same strategy. We need to find optimal level of output in the short run, right? So simply we use the into the profit maximization output, right? That's 4 times L to the power of 1/3 times K bar 1/3, which equals to 4 times 8 to the power of 3/2 times 1/3 times 64 to the power of 1/3, which will become 16 times 8 square root of 8. Okay. Square root of 8 is 2 times square root of 2. Okay, which means 32 times square root of 2. And therefore, we got our profit maximization output level equals to 32 times square root of 2. Okay. And next thing, obviously, what we need to do is to get short run optimized profit. okay, or maximize profit. Simply we're plugging L into the profit maximization equation, okay? Pi star SR will equals to 48 times L to the power of 103 minus L minus 64, which equals to 48 times 8 to the power of 3 over 2 times 1 over 3 minus 8 to the power of 3 over 2 minus 64. This will equals to 64 times square root 2 minus 1, okay, which is approximately 26.5097. So D is asking us, what is the change in L when W increase from 1 to 2 in the short run? Okay, that's pretty easy, right? Because the labor, the short run unconditional labor demand, we have calculated in both questions. In question A, that equals to 16 to the power of 3 over 2. In question 2, that equals to 8 to the power of 3 over 2. All right, just this one minus that one, we got 64 minus 16 times square root 2, which is 16 times 4 minus square root 2, okay? That's the change of labor in the short run, okay? So now consider the firm in the long run. Finally, we're talking about long run, okay? So this will be slightly getting more interesting because we need to derive 2 first order conditions and as well as the full hashing matrix, okay? So how do we do that, okay? So let's take a look. If you can see that, suppose that we denote K and L together. Question is asking us if we're having the increasing or decreasing constant return to scale. If you remember, how do we do this? It's simply that we're timing both inputs by 2 or any positive value, okay? So by doubling K and L, we have function of 2L and 2K. This will equal to 2L to the power of 1 over 3 and times 2K to the power of 1 over 3, okay? So therefore, we have 2 times 2 to the power of 2 over 3 times L to the power of 1 over 3 times K to the power of 1 over 3. And as you can see, L to the power of 1 over 3 and times K to the power of 1 over 3 is exactly the production function, okay? So as we can see, 2 to the power of 2 over 3 is obviously smaller than 2 times FLK, right? Because 2 is greater than 2 to the power of 2 over 3, right? So if we have smaller, we know this is decreasing return to scale, okay? That's pretty simple. And question F, suppose that W is equals to 1, which is wage rate. We need to calculate the long run profit maximization profit maximization K and profit maximization L and the profit maximization output, okay? So long run profit maximization problem is pi equals to P times 4L to the power of 1 over 3 times K to the power of 1 over 3 minus W times L minus R times K, which equals to 3 times 4L to the power of 1 over 3 times K to the power of 1 over 3 minus L minus K, which equals to 12 times L to the power of 1 over 3 times K to the power of 1 over 3 minus L minus K, okay? So if we're having this equation, what we need to do next is simply do the first order conditions against L and against K. Let's do L first, okay? Change pi against change L is simply 12 times 1 over 3, bringing 1 over 3 to the front, times L to the power minus 2 over 3, times K to the power of 1 over 3. Nothing changed here because this is simply first derivative against L, not K, and then minus 1 equals 0, okay? And the first order condition for the change of K equals to 12 times 1 over 3 times L to the 1 over 3, nothing changed to L, okay? Times K to the power of minus 2 over 3 minus 1 equals 0, okay? And we're naming those two equations as equation 1 and equation 2. Next thing I need to do is dividing equation 1 by equation 2, okay? This is simply, as you can see, if I delayed all those kind of stuff, this is probably easier to say. 12 will cancel out. 1 over 3 will cancel out, right? Because they are constant number and it's showing up both in the bottom and the top of the equation. And if we're bringing 1 minus 1 to the right-hand side, this will become 1, 1 in the right-hand side. So in the right-hand side, we preserve 1, okay? So therefore, what we'll get left is L to the power of minus 2 over 3 times K to the power of 1 over 3 over L to the power of 1 over 3 times K to the power of minus 2 over 3. which if we simplify this, this is simply K over L equals to 1. Okay. And we call this equation number 3. Okay. K over L equals to 1. So next thing we need to do is substitute equation 3 into equation 1. Okay. So as you can see, equation 1 says it's 12 times 1 over 3 times L to the power of minus 2 over 3 times K to the power of 1 over 3 minus 1 equals 0. And we know equation 1 is K equals L, right? K over L equals 1. So next thing we can do is just substitute K into L. Okay. So we have 4 times L to the power of minus 2 over 3 times L to the power of 1 over 3 minus 1 equals 0. Simplify this, we know L to the power of minus 1 over 3 equals to 1 over 4, or L equals to 64. Okay. Remember that this is something no longer short run. This is a short run demanded of labor equals to 64. Okay. So again, because we have condition number 3, that is K over L equals to 1, then we must know the optimal level of long run capital is K equals L equals to 64. So K star LR will equal 64. That's first order condition. Next thing we need to check second order condition, right? So how do we check second order condition? We need to deal with the Hessian matrix. Okay. So Hessian matrix require us to derive pi LL, pi KK, pi LK, and pi KL. Okay. In a sense, this is simply P times the own effect and cross effect, right? So FL is simply change of pi L squared over change of L squared, which equals to minus 8 over 3 times L to the power of minus 5 over 3 times K to the power of 1 over 3. Okay, obviously it's more than 0, which is good. Next, we check pi KL, okay, pi LK. Pi LK, which, because they are cross effects, so pi LK will actually equals to pi KL, okay? On the off diagonal, they will be exactly the same, okay? As we derive this, this will equals to 4 over 3 times L to the power of minus 2 over 3 times K to the power of 2 over 3, which is exactly the same, okay? Which is greater than 0. Next, we have pi KK, which is the lost item in the diagonal, the main diagonal, pi KK, which is change of pi squared over change of K squared. Okay, which means it's second derivative of the perfect function, which equals to minus 8 over 3 times L to the power of 1 over 3 times K to the power of minus 5 over 3. Obviously, this is smaller than 0. Now we check that whether we have our own effect greater than cross effect. Okay, how do we check that? It's simply with letting pi L times pi KK minus pi LK times pi KL. If we derive this, this is simply 16 over 3 times 64 over 9 times L to the power of minus 4 over 3 times K to the power of minus 4 over 3. And obviously, because those two terms are positive, so therefore this will be positive, okay? Which indeed shows out that the own effect is greater than the cross effect, okay? Since we satisfied condition 1, yes, condition 2, yes, condition 3, yes, the Hessian matrix is negative definite, which means the second order condition is satisfied. This is exactly 3 conditions required for the second order condition to be satisfied when we're having a long run model, okay? So if that's satisfied, we can finally plug in LR star and KLR star into the production function. Then we get the perfect maximization output. YLR star equals to 4 times LR star to the power of 1 over 3 times KLR star to the power of 1 over 3. And we know LR star equals to KLR star, which equals to what? 64, right? Plug in the value. We get this 64 to the power of 1 over 3. That's 4. 64 to the power of 1 over 3. That's 4. 4 times 4 times 4. 4 to the power of 3. 64. Okay, easy. Next thing one need to do is to substitute this into the perfect function. Okay, so the perfect function, when we know the maximized perfect is P times 4 LR star 1 over 3 times K LR star 1 over 3 minus W LR star star minus R times K LR star. Okay, so actually we know all those values, right? So this was simply because W equals to 1 and R equals to 1. Okay, this is simplified to minus LR star minus KLR star. So we have 3 times 4 times 64 to the power of 1 3 times 64 to the 4 to the power of 103 minus 64 minus 64. Again, this way equals to 64. So our maximized profit will be 64. Okay. Level G, now suppose W equals to 2. Again, when you do this in the long run, the process will be exactly the same. So we'll be maximizing our profit against change of L and K. This will be equals to P price times the quantity for L103 times K103 minus the cost. Okay, the cost is W times L minus R times K. Okay, so now W equals 2. Okay, so this becomes 12 times L to the power of 103 times K to the power of 103 minus 2L minus K. Okay, so then we have our first order condition. Okay, exactly the same thing as before, just taking the first derivative and set it into 0. Okay, so as you can see, the only difference here is the first order condition for labor, which instead of -1, we have -2 here. Okay, and change of pi over against K, which is the first order condition for capital, is exactly the same as before. So what we need to do is equation 1 divided by equation 2. So instead of having 1 here, we have 2, okay? Because here -2 minus 1 divide 2 over 1, we have 2, okay? So in the end, we have K over L equals 2, okay? That's easy. That means K equals to 2 times L. Also means K star long run will equals to 2 times L star long run, okay? Easy. So next thing we need to do exactly the same as before is that we substitute equation 3, which is K equals 2L, into equation 1. In equation 1, we have derived the first order condition for change of labor. Okay, so therefore we simply replace K with 2L. Right, so therefore what we got left is an equation with L on it. Okay, L to the power of -1 over 3 will equals to 1 over 4 times 2 to the power of 2 over 3. Alternatively, this means L equals 64 times 2 to the power of -2. Okay, which means 16. So now we know the long run optimal level of labor is 16. So how do we get the long run optimal level of capital then? Remember, we have the function 3, equation 3 saying K equals to 2 times L, right? So therefore K star will equals to 2L star, okay? So therefore K equals to 2 times L equals to 2 times 16, which is 32. So we know the long run optimal level of the capital will equal 32, okay? So second order condition is satisfied, okay? Obviously, I'm not going to repeat it. It's going to be exactly the same as this part, okay? So in the exam, or probably say in the future, just copy and paste it. It's exactly the same, okay? As soon as you see this minus sign, then you know first two conditions satisfied. Then all you need to check is the own effect greater than cross effect, okay? I'm not going to repeat that. It's exactly the same, okay? Cool. So if second order condition is satisfied here, then I know they are profit maximization inputs, right, in the long run, 16 and 32. Then I can plug them into the production function to have the profit maximization output, YLR star, okay, which equals to 4LR star 103 times KLR star 103. And we know LR star is 16. And we also know KLR star is 32. So plug in the value, 4 times 8 is 32, okay? So profit maximization output is 32. Next, we have the maximized profit, okay? So simply just plugging this into the profit function. Again, this is a revenue minus the cost, okay? So remember, here's no longer 1 because the wage rate is 2 now. So plugging all the number, 3 times 4 times 16 to the power of 103 times 32 to the power of 103 minus 2 times 16 minus 32 is 32, okay? So therefore, the profit is pi LR star equals 32, which obviously is greater than 64 times square root of 2 minus 1, which is 26.5097. And remember what is this? This is what we derived in question B, which is something we call the maximized profit in the short run. Okay, so as you can see, the maximized profit in the long run is obviously greater than the maximized profit in the short run. So therefore, we say that the pi LR star is greater than pi SR star, because a firm can always choose a short run level K star, K bar, if it wishes so. However, when we need to adjust K to get optimal K star, the extra flexibility in the long run allows firm to earn a higher profit, right? So as you can see, this makes sense, right? Easily makes sense. Why? Because in the short run, you can't change the capital level. So all you got is changed labor, okay? So the space you got to play around to maximize your profit is smaller. So therefore, if you allow yourself to change the capital as well, which means in the long run, you will obviously have a higher output, okay? So I believe there's one more question. Question H is simply asking you to compare the labor level, which is 16 comparing against 64. Okay, obviously 64 is greater than 16. Okay, which is very easy. Do you have any questions, guys? How are you?
No, I think it's all good.
Okay, excellent. Then we're done with this week's tutorial. So one more thing. So next week, due to some family issues or personal issues, I wouldn't be running the face-to-face or the tutorial on time. I would just simply upload the recording. Okay, I will do this before Friday.
Yeah, thank you.
Okay, cool. All right, thank you. Bye. How you have a good weekend.
Bye-bye.